Monday verse, Colossians 1:16 through 17. For by him were all things created, that are in heaven and that are in earth, visible and invisible, whether they be thrones, dominions, principalities, or powers. All things are created by him and for him, and he is before all things, and by him all things consist. Yes, Wesley?
I was not able to come in and take my test on Friday, finish it. May I finish it today during my G block?
Well, you can, but it loses 2 points now. Okay, because you had the whole weekend. All right, so that was not a very good move. All right, now, remember we're talking on 76. We started 76, which is about even and odd functions. We talked about the sine function being an odd function because on the other side of the axis, you were going to see it dip down and come up again. Okay, so this one was a reflection across the x-axis on this side, but the equation that goes with the odd is that f of negative x is equal to negative f of x. And if that's true, or you can show that is true, then the function is odd. All right, so then we talked about the even function. The cosine is an even function, and even functions look the same on each side of the axis. There's a symmetry about the y-axis in an even function. And an even function is f of negative x is the same as f of x. That is an even function. All right, and then I showed you that if we took y as x squared, that is also an even function, because if I plug in a negative x, y is negative x squared, the negative squares out, and it becomes the same as whatever x squared was. Okay, so you can put a negative x in there, and it's not going to make any difference because it's even. The x squared, negative x is going to square out. So then, the part we didn't get to do last time is starting to talk about how this affects all of our trig functions. Okay, is when we're looking at these, so we've got sine, cosecant, tangent, and cotangent. Remember, the sine and the cosecant are the reciprocal functions of each other. S goes to C and C goes to S, remember? And the cosine and the secant are reciprocal functions of each other. So it makes sense that if this one's even, and it is, then its reciprocal function would also be even. Okay? This one is even, its reciprocal function, odd, its reciprocal function is also odd. This one is odd, and this one is also odd. Okay? Now what we're going to start doing is start taking these things and saying, okay, using these principles to simplify expressions that we see. In other words, cosine of negative theta is more complicated than cosine of theta. If we understand that cosine of negative theta is the same thing as cosine of theta, then we know how to deal with it, all right? Sine of negative theta, you'd look at that and you go, huh? Well, I don't know what to do with a negative theta in there. But if you understand that it's the same thing as the opposite of the regular sine of theta function, then it's going to take the mystery out of that, okay? So let's look over here to the next part here. Any questions on the even and the odd functions? Now, when you're looking at this, if I told you to prove that tangent of negative theta was the same thing as negative tangent of theta, how could you go about it if I ask you to prove that? Okay, which I will be asking you things like that. Could I say that tangent of negative theta is the same thing as sine of negative theta over cosine of negative theta? Could I say that? Because I've told you over and over, the tangent is just the sine over the cosine, isn't it? So then, could I look up here and say, well, but the sine of negative theta is the opposite of sine theta. So that becomes opposite sine theta. And the cosine of negative theta becomes...
Opposite cosine.
No. Cosine theta. It's an even function, so they're the same. Cosine negative theta and cosine theta are the same, so cosine theta and negative sine theta over cosine theta would be what? Negative tangent theta. So you can do little proofs like that, and that's what you're going to be doing with these. Little proofs on whether it should be an even or an odd function based on that.
What about the cosine theta? How do you prove that? The cosine negative
On these are kind of like your identities here. The cosine negative theta, if you're looking at the graph of the cosine negative theta, and you can see that when you plug in, or suppose you plug in a cosine of 30 and a cosine of negative 30, what's going to happen? What is cosine of 30? Okay, here's my 30. My cosine is my long one.
1/2.
No, square root of 3 over 2. All right, but cosine of negative 30, where the 30 is going down, cosine is still positive over there, isn't it? It's still going to be square root of 3 over 2. So both of these are square root of 3 over 2. Square root of 3 over 2. Okay, both of them are. So it's going to make no difference. And then when you move into the second quadrant, isn't that going to be mirrored by whatever happens in the third quadrant? Because they're going to be the same distance from 0. And it's going to do that thing, right? It's going to be symmetric about the y. All right, so now everybody go down here to 76b. And 76b is talking about the functions of the other angle, okay? And if you have your calculator out, pull it out. This is a nice little calculator exercise so that you can see the functions of the other angle, okay? And they're showing you down here a triangle, a right triangle, and they're saying, okay, here's B, this one is going to be A, this one is going to be C, and this one's going to be theta, and this one, of course, is going to be 90 minus theta. Okay, and when we start to go through if we're going to call theta, we know that the sine of theta is SOHCAHTOA, right? So the sine opposite over hypotenuse is going to be A over C, isn't it? A over C. Okay, the cosine of theta is going to be what? B over C, right? The adjacent over the hypotenuse. The tangent of theta is going to be what? Opposite A over C, right? A over B. A over B, thank you. Opposite over adjacent. All right, then what about those sister functions here, the reciprocal functions? The sine goes to the cosecant, doesn't it? So the cosecant of theta is going to be C over A. The secant of theta will be C over B. The cotangent of theta will be what? B over A. Okay? Now, once we see that, let's look at the other angle. Now, what they're talking about is we know that this one's always 90. This one's whatever theta we have, and this one's got to be the other angle, 90 minus theta, right? So let's look and say, okay, what is the cosine of 90 minus theta, that other angle in the triangle? And the cosine of this one is going to be what? Adjacent over hypotenuse. It's going to be A over C, isn't it? And the sine of 90 minus theta is going to be what? Here's my angle, opposite over hypotenuse, or B over C. And the tangent of 90 minus theta is what? Here's my tangent. The tangent of 90 minus theta is opposite over adjacent, B over A. All right, so now what we're talking about here is notice this correlation. Then I'm going to let you try with your calculator. The sine of theta is the same thing as the cosine of the other angle. Okay? The cosine of theta is the same thing as the sine of the other angle. And then the tangent of theta is the same thing. We don't have it up here, but it's going to be the cotangent of the other angle. 90 minus theta, the cotangent of 90 minus theta is going to be what? A over B, isn't it? So it's going to be A over B. So we have this list here. They're going through the development here, but notice on the next page, they've got all of these identities down here for you. Tangent of A is A over B. The cotangent of the other angle is A over B. Okay, the cotangent is B over A. That's going to be the same thing as the tangent of the other angle. 90 minus theta must also be B over A. Okay, now when you're dealing with your unit circle, you already know this. Cosine, sine, tangent. All right, so when we start looking at our unit circle, if we start at 30, what is our cosine of 30?
Square root of 3 over 2.
Square root of 3 over 2. What's our sine?
1/2.
1/2. What's our tangent?
0. Undefined.
It's going to be the sine over the cosine, or 1 over square root of 3, which is square root of 3 over 3. Okay? All right. What about my 60? Shh. What about my 60? The cosine of 60 is 1/2. The sine of 60 is square root of 3 over 2. And the tangent of 60 is going to be the what? It's going to be the sine over the cosine, which is square root of 3. Okay? Then I could go on and do the rest of them. But look at this relationship. And it's been staring at you in the unit circle all that time. Okay? So, and that happens with everything. So, everybody get out your calculators and find out what the sine of 15 is. And figure out what the cosine, what would be the other angle?
Square root of 6 minus square root of 2 over 4.
75.
0.2588.
No, okay, this one is what? 0.2588. And then this one, just give it to me in decimal. Just, yeah, I don't need exact, I just need decimal. What's this one going to be?
0.965.
No, the cosine of not 15. What's the other angle? Cosine of 75. What is the you see what I'm saying? 0.2588. These two angles add to 90. That's what they're talking about, the angle and the other angle. Who's absent? Mark's absent. Who else is absent?
David's here. He just can't.
Okay,
come
so
to class.
okay, David can't come to class, but is that it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
David,
Mark.
Wade.
Wait, yeah. Okay, all right.
Wade's
fine.
not in this class anymore.
Wade's not in the class anymore. Okay, so here we go. Shh. So this relationship is going to happen everywhere in the unit circle. So if you are asked to find the, you are given maybe on a piece of paper, like on a mu alpha theta test, okay, and they gave you the sine of 10. If the sine of 10 is blank, okay, then they could ask you in the string what other function is the same thing, and you would have to say the cosine of 80 would be the same thing as the sine of 10. Exactly the same. Okay, so that's what our other angles are doing for us. Okay, now we're starting in to this cool trigonometric identities. This is the best part of the book. This is always the most loved, excuse me, the most loved section of all. Okay, and this is trigonometric identities. Okay, and the most famous of all trigonometric identities is going to be this one: sine squared theta plus cosine squared theta is equal to 1. All right, well, let's play with this. If I just take this one right here, okay, and I said cosine of 30, sine squared of 30 plus cosine squared of 30 equals 1. Let's see if that's true. Okay, when I go through, what is the sine of 30? Sine of 30 is the big one, right? Square root of 3 over 2. Square root of 3 over 2, quantity squared. Plus, what's the cosine of 30? 1/2, right? No. Wait. I'm
Sine of
confused.
30 is
Sine of
1/2.
30. Sine of 30 is the 1/2. My bad. Y'all are just letting me make all kinds of mistakes. Well, wake up. Let's all wake up. All right, now is that true? The cosine of 30 is the long one. The sine of 30 is the short one, right? So then, is that true? When you square this side, Wesley, what do you get?
You get 1/4.
Very good. When you square this side, Duncan, what do you get?
3/4.
3/4. Do you wind up with 1? Yes.
Roll.
Okay, so anywhere on the unit circle, we could take 45. Cosine squared 45 plus sine squared 45 is 1. Is that true? What is cosine 45?
1/2 or square root of 2 over.
Square root of 2 over 2. What is that squared, Ian?
2/4.
2/4. Very good. And then this one's the same, isn't it? Square root of 2 over 2 squared. And when I add them together, it's 2/4, and I get 1. Will happen everywhere. Okay, that is your identity that you can hang everything
Wait, Miss
on.
Aldridge, if we're just now going over this, how come we've had those problems on the test before?
This one, you have not had this identity problem on the test, but you will.
Every time we've had a problem like this, though, it's always
That's
good.
communist.
You will not. You have not had this one yet. Okay. Now look at trigonometric identities. Now we're going to the trigonometric identities are things we can hang our hats on. We have a few of them. Cosine of theta is 1. No, the cotangent of theta. Cotangent of theta is 1 over the tangent theta. These are rules. Secant of theta is 1 over the what? Cosine of theta. Cosecant of theta is 1 over the sine of theta. So you see those at the top of 76D. All right. Now, everybody, look over here we get to start show me problems. And show me problems are just about the best things in the world. Okay, sine x, and we're going to show the first one. Show that cotangent x over cosecant x is cosine x. All right, now this is how a show me problem goes. Watch carefully. You're going to be doing show me problems until the end of the book, and you're going to try to do them the wrong way, and I'm going to count off points. Show me problems, okay? Whenever you're doing a show me problem, you always start with the left, and you move to the right. You can't start at the middle, you can't start at the back and move this way. You've always got to start with the left. Okay, and this is the way I do them. You don't have to do them exactly the way I do them, as long as you do them correctly. I change my cotangent, and I change everything into sines and cosines. Okay, so a cotangent, if the tangent is the sine over the cosine, what is the cotangent? Isn't it the cosine over the sine? Okay, would everybody agree? The cotangent, if the sine is the sine over the cosine, the tangent is the sine over the cosine, then the cotangent is the flip of that. All right, so that's going to be that. Now, what about the bottom? What is the cosecant? Cosecant is 1 over the sine of x, isn't it? Okay, now what would happen if I multiply by 1 now in the form of sine of x over sine of x? What do I get? What's going to happen?
It's going to be
I get the cosine over 1 or just the cosine of x. What was I trying to prove? Cosine of x.
They're just proofs.
They're little proofs. They're little proofs. They're little show me's or just little proofs. And you're using the little identities to show the little. Okay, look at the next one. Sine of x, cotangent of x is 1 over secant of x. Okay, now I'm going to start with the left, right? I don't mess with the right. So I start with the left. Sine x, cotangent x equals. Well, the sine x is already in the right form. Sine x times, what is the cotangent x? I just turned this one into it, right? It's the cosine over the sine. Leave them alone. The cosine over the sine, right, is equal to the what? The cosine of x. Now, how am I going to get from the cosine of x to the 1 over the secant of the x? Isn't it? Okay, the cosine and the secant are the reciprocal functions. All right, so that's an identity, isn't it? The cosine is 1 over the secant of x. And I can get there, okay? Everybody turn to the next page. Look at the last one. The last one, it says, okay, the next one is cosine of negative theta, sine of 90 minus theta is cosine squared theta. So I start on the left, and cosine of negative theta, sine 90 minus theta. What is the cosine of negative theta? We talked about that at the beginning of the book.
Cosine theta.
It's the same thing, right? It's an even function, so cosine of theta, cosine of negative theta is the same thing as cosine of theta. What about this one?
That's the same as cosine theta.
It's the same as cosine theta, right? Because the sine of the other angle is the same thing as the cosine of the original theta. So this is cosine theta. So what does it become? Cosine squared theta. Isn't this cool? This is like the most fun we've had all year.
I know.
All right, so everybody, we're not going to get to do 76 today. 77 today because it is a short day. So we're going to have to move 77 and book it tomorrow. But listen carefully. Your homework today was, let me turn this off. Your homework